What if two of the greatest minds in physics history both got time completely wrong? Albert Einstein gave us spacetime. Richard Feynman gave us quantum strangeness. Between them, they reshaped everything we thought we understood about reality. But what if the very thing they built their lives around, time itself, was something neither of them truly grasped? Stick with me, because by the end of this video, you'll see why modern physicists are quietly whispering that both giants might have missed the deepest secret of all. Let's start with Einstein, because before Feynman ever stepped into a lecture hall, Einstein had already broken the rules. In 1905, he told the world something shocking. Time isn't fixed. It bends. It stretches. It slows down depending on how fast you move. Two clocks, one on a fast plane and one on the ground, will literally tick at different rates. And Einstein didn't stop there. In 1915, with general relativity, he showed that gravity itself warps time. A clock near a black hole runs slower than a clock floating in deep space. This wasn't science fiction, mate. It's been measured. GPS satellites have to correct for it every single day. Otherwise, your phone's map would drift kilometers off course. But here's where Einstein went even further, and this is the part most people miss. He believed time and space weren't separate things. They were stitched together into one fabric, space-time. Past, present, and future, in Einstein's view, all exist at once. He once wrote that the distinction between past, present, and future is only a stubbornly persistent illusion. Think about that for a second. Einstein looked at the universe and said, "The now you're feeling right now isn't really moving. It just feels like it is." That's a wild idea, and for decades, physicists accepted it as something close to gospel. But then came Feynman. Now, Richard Feynman wasn't out to destroy Einstein. He admired him deeply. But Feynman was a quantum man. He lived in the messy, weird, probabilistic basement of physics, the place where particles don't pick a path. They take every possible path at once. And when Feynman started looking at time through that lens, things got strange very quickly. Here's the twist that changed physics forever. Feynman, working alongside John Wheeler, suggested something almost unbelievable. What if a particle moving backward in time was the same thing as its antiparticle moving forward? In other words, a positron isn't really a separate object at all. It's just an electron running the wrong way through time. Read that again. Feynman wasn't being poetic. He built actual diagrams, the famous Feynman diagrams where time could flow in either direction and the maths worked perfectly. So while Einstein was painting time as a smooth, frozen river that simply exists, Feynman was showing that at the quantum level, time looked more like a chaotic web, particles zigzagging, histories overlapping, the arrow of time blurring at the smallest scales. And that's where the real conflict begins. Einstein wanted a universe that was deterministic and elegant. He famously said, "God does not play dice." He believed every event had a clear cause, and time, while flexible, was still a clean, ordered backdrop to reality. Feynman, he embraced the dice. He once said he thought he could safely say that nobody really understands quantum mechanics. And he meant it. Where Einstein saw a clockwork cosmos, Feynman saw a swirling fog of probabilities. Where Einstein saw the future as already written into the space-time block, Feynman saw it as something the universe was constantly negotiating with itself, moment by moment, path by path. Two giants, two completely different views of the same thing, time, and they never fully agreed. Einstein died uncomfortable with the randomness Feynman celebrated. Feynman quietly suspected Einstein's smooth spacetime broke down once you zoomed in close enough. Both were brilliant. Both were partly right. And both, in their own way, may have been chasing the wrong question entirely. Here's something most people don't realize. When Einstein looked at his own equations, he was deeply troubled by what they implied about the present moment. He once admitted to a friend, near the end of his life, that the problem of the now was something physics simply could not explain. Feynman, on the other hand, almost shrugged at the question. He cared about what worked. If the equations let particles drift backward through time, fine. If the universe was a chaotic sum of every possible history, fine. He chased what gave the right answer, not what felt right. So you've got Einstein, the architect of order, deeply uncomfortable with what his own theory was telling him. And you've got Feynman, the rule breaker, perfectly happy to let the universe be weird, but quietly aware that something deeper was missing. But here's where it gets really strange. Because in the last few decades, physicists have started asking a question that would have rattled both of them. What if time isn't fundamental at all? What if time, the very thing Einstein bent and Feynman reversed, doesn't actually exist at the deepest layer of reality? This isn't fringe stuff. It's coming from serious physics. The Wheeler-DeWitt equation, one of our best attempts to combine quantum mechanics with gravity, has a haunting feature. When you write it down, time disappears. The equation simply doesn't have a T for time in it. Carlo Rovelli, one of the leading minds in loop quantum gravity, argues that time emerges from something deeper, a bit like temperature emerging from the motion of countless atoms. You don't see temperature on a single atom. It only shows up when billions of them move together. Time, Rovelli suggests, might be exactly the same kind of trick. Julian Barber goes even further. He believes time is an illusion built entirely from the relationships between things, not a thing in itself. If they're right, then both Einstein and Feynman were describing shadows on a cave wall. Einstein's smooth space-time, an approximation. Feynman's zigzagging quantum time, also an approximation. The real universe underneath it all might be timeless. Just relationships, just connections, just change, without a clock ticking behind it. Now, here's the question that should keep you up tonight. If time isn't real in the way Einstein imagined, and it isn't real in the way Feynman calculated, then what exactly are you experiencing right now? What is this thing you call the present moment? Einstein would tell you it's an illusion stitched into space-time, a slice you happen to be moving through. Feynman would tell you it's a sum of countless quantum paths, some running forward, some running backward, all adding up to the moment you call now. And modern physics, it's starting to whisper something even more unsettling, that maybe, just maybe, time is something your brain invented to make sense of a universe that doesn't actually need it. Think about that for a moment. Two of the greatest minds who ever lived spent their careers wrestling with time. Einstein bent it, Feynman reversed it. And the deeper we look, the more it seems they were both circling a truth neither of them could quite reach. Maybe time isn't a river. Maybe it isn't a web. Maybe it's the silence underneath the music. Something we only notice because everything else is moving. So here's the question I'll leave you with. If Einstein saw time as a fabric and Feynman saw time as a quantum dance, what would you call this strange feeling of now, the one slipping through your fingers even as you watch this video? Drop your answer in the comments. I genuinely want to hear how you see it. And if this made you think, hit subscribe, because next time we're going even deeper into the questions Feynman quietly believed physics still hasn't answered.